before we wrap up this episode, I feel like we've got to talk about DeepSeek.
Yeah.
It's what everyone's talking about these days. And so uh, you wrote to me in an email that DeepSeek crushed OpenAI and Anthropic. What do you mean by that?
Well, I made a post, by the way, on this last week, so I refer everyone to read more in detail. So I think that DeepSeek is probably the most important thing that happened to language models since the release of ChatGPT. And it's not in terms of, okay, this model beats that model. We already saw multiple examples when some new model beats a previous one, and then the company that created the previous model releases something new, and now again it's state of the art. So it's not in this sense. It's more in the sense that what DeepSeek did, I will probably enumerate. So the first thing they did, they trained a state of the art model by using a very tiny budget. So what previously was considered like needing maybe a 20, 30, 50 million dollar to train a new kind of a version of some model, now it takes probably 5 to 10 million. So it's about like 500% decrease. So this is one. But again, if they kept this only for themselves, well, everyone would say, okay, well, they're lucky. They don't spend a lot on their models, but so what? Others have money, so nothing changed. But what they did, they actually has shown everyone how to do the same thing, like as a recipe, as a step by step. So now not only you know that a very competitive model can be created with a small budget, now you can create one for yourself. So they published this public technical report, and already online you can find several independent implementation of the R10 and R1 training. So anyone can do it. This is two. The third is that not only they're more cheaper to train, they're also much cheaper to run. So if you compare the pricing of let's say OpenAI for O1, it's about $60 for a million output tokens. 60. So like it's probably I don't know, you will spend 5 minutes talking to it with sufficiently long context, for example, talking about some book or some article, and you will pay $60 like in 5 minutes. And what DeepSeek shows is that their model, they charge $2 for a million output tokens. So again, it's like 30 times reduction in cost. So not just anyone can train it now, but anyone can run it, and it will be very efficient. So like if you take all of this, they kind of they gave the state of the art AI to anyone, to to your brother, to your grandmother, so they can just make it and have it. And this is what was considered OpenAI's or Anthropic's secret sauce. And and the final thing, not just because when you create language models, it's not just about compute, and it's not just about knowing how. It's also about having the right data. And the data was always what we call the moat. Like companies like OpenAI and Anthropic, they invested a lot in creating high quality data for the model fine tuning. So because like when you just pre-train it, it cannot talk. It's just the next word predictor, and then you must convert it into a chatbot. So it takes questions, it output answers, and then you also must convert it into a problem solver. So not just you ask questions and expect answers, but you also have to have some sort of multi-step interaction where you solve a problem, for example, a coding problem, jointly with the LLM. So to make LLMs act like this, you need examples of this problem-solving conversations. And those examples should not be, some random stuff. They should really be to the point. Okay, let's solve this specific problem. So to create such examples, you need subject matter experts. So having such subject matter experts available to create hundreds, even thousands, even hundreds of thousands such examples, it's a huge investment. So I think that they invested billions just in getting those conversations. Now, DeepSeek, they have shown that you don't need that. So basically, their approach to training R1 is based on automated validation of solutions. For example, let's say you ask it to generate some code. It generates this code, and instead of like previously, you would ask a subject matter expert to look in the code and say, yeah, makes sense, or no, I don't like it, it's too long. They run the code, and once the code is executed, they take the output and then compare it to the ground truth. So what was supposed to be the output? Or just it compiled, that's it. It's a signal, like for reinforcement learning, it says 1, it's compiled, 0, it crashed. The same for math. So they have a math problem. They know the solution. The solution is 42. Okay. And they ask the LLM that they train to generate a bunch of solutions. And if one of them gives 42, they say 1. For the rest of them, it's 0. So, and for the logic, it's the same thing. So you can create a kind of a logical derivation, like you have this hypothesis, and then you try to derive whether this hypothesis, this conclusion is true. You can verify the logic, so you can create this task automatically. Again, your LLM tries to solve this logic problem, and in the output is the killer is the cook. Okay, so you see whether the output is cook, and you say 1, the reward is 1 because it's cook. If it's something else, reward is 0. So creating such examples are very simple. For example, you take a GitHub repo, you hide just one class from it, and you ask the LLM to fill this class. So write it from scratch, and then you compile the full repo. If it compiles, cool, the reward is 1. If it doesn't, reward is 0. So you don't need subject matter experts anywhere in this pipeline. So they created like hundreds of thousands, close to 1 million such examples fully automatically. Again, like it removes this mode that was previously only available to companies with big budgets. Now again, you can just recreate this training set at home and create R1 named after you. So they kind of removed any competitive advantage the biggest players had, and they had this advantage for 2 years. And even I remember a year ago, the OpenAI folks, before everyone left, they gave an interview, and some journalists asked them like, okay, you see there is a huge movement of open source LLMs. Are you worried about that they can even probably undermine your business models? And they laughed at like, no, with someone with someone working at home with a tiny budget, there is so much they can do. They don't have data, they don't have compute, and now everything of what they mentioned is gone. So now we are kind of at square one. What's next? So this is the biggest revolution I would say that R1 did. The model itself is good, but it's not about the model. It's about the fundamental change in how open LLM is, like the notion of open LLM changed and what it can do now.
Very well said. Earlier, you mentioned open weight LLMs. So Llama models from Meta, for example, are open weight. They're not open source because you can't see the source code. Would you say that these models from DeepSeek are actually open source?
Well, my personal opinion on this is much stricter than for some others. For example, Jan LeCun, he calls Llama open source models. In my definition, because like LLM, like what does open source mean? Not in terms of a formal definition, but in terms of practical aspect. Open source in software means that anyone can reproduce your software independently. So you put the source code online, anyone can download it, tweak it, kind of adapt a little bit to their system, run, and get the same software as yours. But with LLMs, it's not like this. So you cannot take just the model itself and say that you and run it locally and say that you reproduced it. No, the model itself, it's similar to the binary. For example, you download, I don't know, GIMP, graphical, so open source graphical editor. So if you just download the binary, it's not open source. Or you download Adobe Acrobat, or you download Word. You can run it online. Or you can run it on your machine, but you don't call it open source. You can use it. You can access to its binaries, but you cannot tweak it. You cannot update it and make it different. And this is what open source is. So with open models, if you want to reproduce this model at home, you need not just the code that was used, but you also need the data that was used, because the model is nothing without the data. So from this perspective, these open weight models, they are open weight, but they are not open source. And there is, I mentioned in the beginning, there is a bunch, maybe a couple of models that come not just as open weights, but also you can download the full training data set that was used to train it. Unfortunately, it hasn't become a standard practice of releasing new models. So these models with open data set, they're no longer competitive today. So if you want, you can take the data set and you can train a new model based on it. But again, by today's standards, a typical data set for pre-training today, it's between probably 15 and 20 trillion tokens. So again, if you download some openly available data set, it will be maybe 4 or 5 trillion tokens. So you cannot really hope to reach state of the art when you have 4 times less data.